This is Darren Marchant with American Nomad News, and I am here to tell you all about some new thoughts that I'm having. Actually, they're kind of old thoughts, but I'm updating an idea for appropriate human-powered propulsion on Mars. Now, considering that Mars is 1/3 the gravity of Earth, that means that there's a fairly simple calculation, a ratio, where a person that feels 100 pounds on Earth would still feel 100 pounds on Mars by extending the load on the body, using muscles and bones for shock and compression and extension, rotation, and all of these motion functions that we can apply with energy just for feeding us and taking care of our bodily requirements. On Mars, that ability to push more mass for the same amount of leg thrust that it takes on Earth to move, say, for me to pedal a bicycle with an extra 100 pounds and a cart on the back on a flat ground, how much energy is that, right? Well, you have the ability to carry much more than that load in the same setup on Mars because of the 1/3 gravity, which means that if you added until your legs were feeling the same resistance as they would feel here on Earth, you put load cells in bicycle pedals and have guys on Mars pedal around and verify that what we calculate it to be is actually the amount of force you would expect on those pedals, that is equal to what it would be like to do that same thing here on Earth. So if we look at a cartoon, the Flintstones, right, they joke about having foot power. The feet are sticking out the bottom of the stone-wheeled go-kart, and you hear a patter, patter, patter sound, and the little feet animation goes by. But what if we take two identical bicycles, the kind that have the really like 4-inch tires, the new ones, but the rims are basically still bicycle rims, a little beefier, and it's basically a mountain bike. You take two of those and cut out the crossbars between the front and the back segments, between the seat post and the gooseneck. Take those two pipes out, stack them on the shelf. You might be ready to use them later. Clean and dress up the marks where you welded it, and there you have components to build a covered wagon that's steered in the same pivot axle manner that you see on old covered wagons, but made out of bicycle parts and very light. Well, I've thought about this for a while, and you could have one that's just like a bicycle, only shaped out like a truck, and you could carry a load in the back of the truck, but instead of a front end of the truck, and all of that steel and stuff, you have a very light mountain bike kind of framing, and shock absorbers in key components, so the whole body can flex a little bit. You can bounce around quite a bit, and it's not going to break loose of those joints you might be tempted to weld on a car and make a rigid body. You make a very flexible body, and you have a portion that sits on top of your drivetrain that's a rigid seat, probably like a semi-reclined thing, like you see these guys laying back on the 3-wheeled bicycles and just zooming along. Have a setup like that in the cab of the vehicle, and just a regular straight steering wheel. There's a couple other ways to do it. But if we expand on that a little bit and make sure that it can carry a fairly solid load of shock and mass on the back, then what we can do, and let me check the time on this thing. That looks like 5 minutes, I think. I hope. Okay. And make a rigid wireframe kind of body out of bicycle parts with thin sheet metal lining the back of the bed, and bicycle tubing going to all the corners. And what you do is you have, and you can, anybody with a solid machine shop and the balls to smelt aluminum can make a cast aluminum frame pieces. And if they have enough of a shop set up, I don't know what that is. Huh, that's kind of odd. Anyway, I'm going to pause this and start a new one. Part one, end of part one.